हम लोग को सॉल्व करना है प्रॉब्लम 1.1। क्वेश्चन है कैलकुलेट द मोलिकुलर मास ऑफ ग्लूकोज। ग्लूकोज का फॉर्मूला होता है C6H12O6 और हम लोग का इसका मोलर मास या फिर मोलिकुलर मास निकालना है। इन ग्लूकोज देयर इज 6 कार्बन atom and mass of one carbon atom is 12 plus there is 12 hydrogen atom and mass of one hydrogen atom is approximately 1 plus there is 6 oxygen atom and one oxygen has atomic mass 16. We have to multiply and add this and we got 180 gram per mole. Gram per mole is the unit of molar mass. Next question. A compound contain 4.07% hydrogen, 24.27% carbon and 71.6% chlorine. Its molar mass is 98.96. What are its empirical and molecular formula? In this question we have given percentage of hydrogen, carbon and chlorine and also molar mass of the compound, and we have to find out empirical and molecular formula of the compound. In this case we have only given percentage. We take 100 gram of the compound for our convenience. Mass of compound equal to 100 gram. So similarly, mass of hydrogen, carbon and chlorine equal to 4.07, 24.27 and 98.96. Next we have to find out moles of carbon, hydrogen, chlorines. Moles of carbon, hydrogen, chlorine equal to mole equal mass open molar mass. Mass of carbon atom is 24.27 and molar mass या atomic mass 12. हाइड्रोजन का 4.07 इसका 1, क्लोरीन का 71.65 डिवाइडेड 35 35.5 equal to 2.021 4.041 2.021. And next we have to find out the stoichiometry of carbon, hydrogen and chlorine. For that we have to divide with a smallest coefficient. Carbon, hydrogen, chlorine 2.021 divide 2.021, 4.041 divide 2.021, 2.021 divided by 2.021, which correspond to numbers of carbon atom in empirical formula 1, 2, 1. Carbon, hydrogen, chlorine, 1:2:1, which means its empirical formula equal to CH2C. In the questions we have also given molar mass of the compound, which is 98.96. Molar mass of compound equal to 98.96. Okay, grams, and masses of this 12 plus 2 plus 35.5 corresponding 35.5, 24.5, 9, 59. N equal to molar mass upon empirical mass. (98.9) upon 59.5. Sorry, yeah, there is some mistake. 49.5, one division which gave 2. Molecular formula equal to N multiply empirical formula 2 multiply CH2Cl, which correspond to C2H4Cl2. Okay, नेक्स्ट क्वेश्चन हम लोग को दिया गया है, calculate the amount of water produced by the combustion of 16 gram methane. We have to first write the chemical equation. Methane combustion, what we got? CO2 plus water. 2 बैलेंस किया जा रहा है, कार्बन 1, कार्बन 1, हाइड्रोजन 4, हाइड्रोजन 4, ऑक्सीजन 4, 2. कैलकुलेट द अमाउंट ऑफ वाटर है, calculate the amount of water produced by combustion of 16 gram of methane. सिंपल सा क्वेश्चन, 16 ग्राम कितना आ जाएगा? 36 ग्राम. So if we take 16 gram of methane, then we got 36 gram of water. 2 multiply 18 equal to 36 gram. Next question, how many moles of methane are required to produce 22 gram carbon dioxide after combustion. Same process. Methane, after combustion we got CO2 plus H2O. क्वेश्चन पूछा जा रहा है हाउ मेनी मोल्स ऑफ मेथेन, इस मेथेन कितना मोल चाहिए टू प्रोड्यूस 22 ग्राम ऑफ CO2. Okay. 16. First we have to balance this equation. 4 2 2 16 gram 64 gram plus 32 44 gram 36 gram. Means if we take 16 gram of methane, then we will get 44 gram of CO2. If we have this 22, we also have this 32 gram, so stoichiometry balance 8 gram. Okay. Next we have to find out the moles of methane. Moles equal to mass, open में molar mass, we have got mass 8 gram and molar mass 16, so moles of CH4 equal to 0.5. This means for the production of 22 gram of CO2 we required 0.5 moles of methane. Next question. 50 kg of nitrogen and 10 kg of hydrogen are mixed to produce ammonia. Calculate the amount of ammonia formed. Identify the limiting reagent in the production of the ammonia in this situation. Okay. First we write the chemical equations for this. Nitrogen plus hydrogen we got ammonia. On placing this equation, this nitrogen with 14 to 28 gram 6 gram, nitrogen 14 3 17 multiplied to 34 gram. In the stoichiometric balance equation, what we observe, if we take 28 gram of nitrogen and 6 gram of hydrogen, then we will get 34 gram of ammonia. Okay. We have given 50 kg of nitrogen, 10 kg of hydrogen are mixed to produce ammonia. Calculate amount of ammonia. हमको इसकी मात्रा निकालना है कितना बन रहा है, और ये भी पता करना है कि इस रिएक्शन में कोई लिमिटिंग रिएजेंट कौन सा है. तो we process now step by step. From the above equation, what we observe, 28 gram of nitrogen required 6 gram of hydrogen. Okay, 1 gram of nitrogen will require 6 upon में 28 gram of hydrogen. If we take 50 kg, then what we will require of hydrogen? 6 upon में 28 multiply 50. One minute. Some problems. 1 minute. Okay. There has been some problems on the slide. I'm just solving this problem. Okay, we have solved this. Okay. I want to bring here a higher calculator, so we will easily solve the equations. Okay, no problems. We must multiply this, and what we got? 300 upon 28. When we divide this, upon 28, we got 10.71 kg. On the reactions, if we take 50 kg, we required 10.71 kg of the hydrogens, and what we have given 10 kg. Means here hydrogen is a limiting reagent, and according to hydrogen the product will be formed. Okay, this large amount, we have only small. If we see the balance equation again, after balancing, six gram of hydrogen produced 34 gram of ammonia. Similarly, 1 gram of hydrogen produced 34.6 gram of ammonia. In the questions, the amount of hydrogen is 10 kg. 10 kg of hydrogen will produce 34 upon 6 multiplied 10. 6 5 is 34. 5.67 multiplied 10, which corresponds to 56.7 kg. This means if we take 50 kg of nitrogen and 10 kg of hydrogen, then we got 56.7 kg of ammonia. Okay, next questions. A solution is prepared by adding 2 gram of substance A to 18 gram of water. Calculate the mass of the solute. Here mass of solute is equal to 2 gram. Total mass is equal to 2 plus 18 equal to 20 gram. Okay, we have to find out the mass percent of solute. Mass percent of solute equal to mass of solute. ओपन में क्या हो जाएगा हम लोग को यहाँ टोटल मास मल्टीप्लाई 100 for percentage टू ओपन में 20 and 200 2, which means correspond to 10% of solute mass percent. Next questions. Calculate the molarity of NaOH in solution prepared by dissolving its 4 gram in enough water to form 250 ml of the solutions. What is the molarity? Molarity is the number of moles of the solute present in 1 liter of the solution. Here mass of the solute equal to 4 gram. Molar mass of solute is equal to 23 plus 1 plus 16, which correspond to 40 gram per mole. Okay, volume solution what have given 250 ml. Molarity equal to number of moles of the solute present in 1 liter of the solution. Moles equal to 4 gram upon में 40 gram per mole multiply 1000 upon volume solution in milliliter. 250 4 0 correspond this 0 ठीक है. $25 4 which correspond to 0.4. Okay, okay. This molarity of the solution is equal to 0.4 mole per liter. Next questions. The density of 3 molar solution of NaCl is 1.25 gram per milliliter. Calculate the molality of the solution. Okay. Here 3 molars means 3 moles of solute, 3 moles of solute present in 1 liter or 1000 milliliter of the solution. Okay, we have given density. Density equal to mass of solution upon molar mass of solution, which mass of solution upon volumes of solutions. Volumes of solution. Density is given 1.25 gram per ml. Mass of solutions is equal to 1.25 gram per ml multiply thousands, which is volume of the solutions. This milliliter and this milliliter will be cut out, and what we got? 1250 gram. This is the mass of the solution. Mass of the solution is equal to 1250 grams. Okay, we have to find out the molality. So in molality we need mass of the solvent. We have also given 3 moles of NaCls. Moles is equal to mass upon molar mass, which correspond to 3, and the solute is NaCl, which is molar mass 23 plus 35.5, 30.5, 58.5. Mass of solute is equal to 58.5 multiplied 3, which 175 gram. Okay, mass of solvent is equal to mass of solution minus mass of solute. Mass of solution 1250 gram minus 175.5. One subtraction, what we get? We got 1074.5 gram, which is the mass of the solvent. Okay, we have to find out the molality. You have to find out the molality, which is mass of solute molar mass of solute, which is moles ratio multiply mass of solvent in gram. mass of solvent in gram. We already given 3 moles, 3, so we write 3 thousands upon mass of solvent, what we given 1074.5, 1074.5. One calculation what we got, 2.79 mole per kg. On the questions we have to find out the molatins, and we have find this 2.79 mole per kg. Okay, thank you for watching this video.